All right, so the current assignments and due dates are here, um, and the next assignment are up is up. So the next thing that's due is on Wednesday, so that's tomorrow. Section 1.6, the written, and the web assignment as well. And then 1.7 and 1.8 are due by Tuesday next week. Uh, it could be helpful for you if you didn't wait until like right before they're due to do them. As we do the sections. So like we finished 1.6 yesterday. So I mean, if you got that assignment done yesterday or today, that would be more ideal than wait until tomorrow. Um, well, I have to give some leeway in the due date anyway. Um, okay. So moving on to section 1.7, um, solving some inequalities. So when you're trying to solve inequalities, it isn't always the same as working with equations. Okay, so some rules, I guess, but some, operations for solving I guess inequality or rules, I guess. So some rules that you can use for working with solving inequalities. Suppose that A is less than or equal to B. Okay, then 1. If you've got this inequality A less than or equal to B, well, you can add C, whatever C is, to each side, and then you get this inequality. Or you can add C or subtract C if C is negative. Okay, so like with equations, right, when A was equal to B, you could always add C to both sides, right? We've done that. Or subtract C from both sides, right? So with inequalities, you can do the same thing. Um, However, when you multiply or divide the inequality on each side, it doesn't always stay the same. So K times A is less than or equal to K times B when K is positive. Right? So you can multiply or divide each side of an inequality by a positive number, and the inequality is preserved. If you do it by a negative number, however, you have to flip the inequality around. Okay, so multiplying by, or let's say, let's do it this way. 2. Then, if K is positive, then K times A is less than K times B, less than or equal to, and minus KA is bigger than or equal to minus KB. So you have to be careful about that with inequalities. Like you have to flip the inequality when you divide by a negative or multiply by a negative. For example, right, 2 is less than 7, right? 2 is less than 7. All right, here's 2, here's 7. It's to the left. But with negative 2 and negative 7, it's the opposite relationship, right? Negative 2 is bigger than negative 7 because negative 7 is to the left of negative 2. All right, so it flips the inequality around. So that's different than working with equations. 3, um, if A and B are both positive, then if you want to take reciprocals, then it also flips the inequality around. If a and b are positive and a is less than or equal to b, then the reciprocal is 1 over a is bigger than or equal to 1 over b. So these are three important properties for working with solving inequalities. So let's start with some linear inequalities. Okay, so solve for x when we have like 3x minus 5 is less than x plus 9. By the way, what is the answer supposed to be when you're solving an inequality? When you're solving an inequality, the answer is supposed to be an interval or, some collection of intervals. An interval or some collection of intervals. Okay, when you're solving an equation, the answer is a number. Right? I mean, if you said 3x minus 5 equals x plus 9, there's a number, x equal to, what is it, 2x, 14. X equal to 7 is your answer. X is equal to 7. Or like with quadratics, you get like two different answers, possibly. Okay, but here, the answer is going to be an interval. Okay, so 3x minus 5 less than x plus 9. So this is solved in the way that you would solve a linear equation. So I'm going to move the x's to the left and the constants to the right. So I'm going to add 5 to both sides. Right, so that's using this property here. You can add 5 to both sides and it preserves the inequality. All right, and I subtract x from both sides and it preserves the inequality. Adding and subtracting preserves the inequality. And now I can divide by 2 on each side, and 2 is positive. 2 is positive, so I can divide by 2 on each side, and it preserves the inequality. So x is less than 7. So there's three ways to represent the answer, right? There's, as an inequality, x is less than 7. On a number line, right, here's the 7 with an open dot because we're not including 7 in the answer. All right, and then you shade in the part of the number line that you're talking about. So here we're talking about everything less than 7. So 7 and everything going off to the left. And then there's interval notation, minus infinity to 7. All right, so three ways to write the answer. All right, as an inequality, interval notation, and graphically. Okay, let's do all three. Let's write the answer all three ways. All right, let's do another example. Linear inequality. So let's do minus 3x minus 5 less than or equal to x plus 9. So again, I'm going to add 5 to both sides, and that preserves the inequality. And I'm going to subtract x from both sides, and that, again, preserves the inequality. But now, in order to isolate the x, I have to divide by negative 4. When you divide by a negative number, you have to flip the inequality. Okay, so I have x is bigger than or equal to minus 7 halves. So 7/2 or minus 7/2 was right there, say. Okay, and we use a solid dot because we're including it as part of the solution, bigger than or equal to, and then we shade in the part of the number line that we're talking about here. So that's the graphic representation of the solution. And then using interval notation, it's minus 7/2 to plus infinity. All right, so 3 ways to represent the answer, and we'll use all 3. Okay. Another thing that comes up once in a while with linear inequalities are these what are known as simultaneous, two simultaneous. So suppose we want to solve for x when minus 4 is less than or equal to 3x minus 5 is less than 9. So this is two inequalities, but they point in the same direction. So right, this is the inequality. Minus 4 is less than or equal to. Let me write it down over here. So this means minus 4 is less than or equal to 3x minus 5, and 3x minus 5 is less than 9. So it's two inequalities simultaneously, but you can write them both, in a single line like that, right? Because the two inequalities contain the same expression, 3x minus 5. And they point in the same direction. They both point to the left. If you had, like, minus 4 is less than 3x minus 5, and 9 is less than 3x minus 5, you can't write them simultaneously like this. You can't write these in clashing directions. Okay, they have to be pointing in the same direction. Okay. All right, so in this, there are, 3 sides. So in such an inequality, there are 3 sides. There are 3 expressions that must be manipulated All right, so like with an inequality or an equation, you have 2 sides, and whatever value you change the one side by, there's a corresponding value to change on the other side, right? So here there's 3 sides, so to speak. Okay, so what I want to do is isolate the x. So I'm going to add 5 to this expression, and to that expression. I'm going to add 5 to the 3 expressions. It's like I was solving this and this at the same time. I would have to add 5 to both sides here and add 5 to both sides here. Okay, so, but rather than, writing them as 2 separate inequalities, we write it all in line like this, and that's fine. So 1 is less than or equal to 3x is less than or equal to 14. And now I'm going to divide each by 3. So 1/3 is less than or equal to 3x over 3 is less than or equal to 14 over 3. And 3 is a positive number, so I don't have to flip, I don't have to flip any of the inequalities. So this gives me 1/3 is less than or equal to x is less than 14/3. So this is the answer in terms of inequalities. On a number line, we're talking about the interval from 1/3 to 14/3 with a closed dot at the 1/3 and an open dot at the 14/3, because the 14/3 is not part of the answer. The 1/3 is, right? 1/3 is less than or equal to x is strictly less than 14/3. And then in interval notation, it's 1/3 14/3 with a square bracket at the 1/3, indicating that we use that as part of the solution, and around parentheses at the 14/3, indicating that is not part of the solution, but everything before it is. All right, so linear inequalities, a lot like linear equations. Quadratic inequalities, this is something a little bit different. Okay, so suppose we have the following. So the thing to remember with quadratic and other polynomial inequalities is that you can never divide by x. Okay, you can never divide by x. By x, by x plus 1, 7x minus 8, etc. Why? Why can't you do that? Right? I mean, with linear inequalities, we divide both sides of the inequality by 3, and that's fine. We divide both sides of the inequality by -3, and that's fine as long as we flip the inequality around. So what's the problem with dividing by x or x plus 1 or 7x minus 8 or something like that? I mean, why can't I do this? Like, say x squared is bigger than or equal to 9. Or x squared bigger than or equal to 9x. So now I'm going to divide both sides by x. What's wrong with what I just did?
Because they're not equal.
Yeah, I mean, but there's an issue with the fact that it's an inequality rather than an equality. And what is that issue exactly? Yes.
You can't square both sides.
No, actually, you can. You can square both sides of an inequality. That's fine. What were we talking about earlier when you multiply both sides or divide both sides of an inequality by k? What's the deal? If you multiply or divide both sides of an inequality by a positive k, so let's write it like this, then the inequality is preserved. Or if you multiply and divide an inequality by a negative value, k, then the inequality gets flipped. So when I'm trying to solve this inequality down here for x, why can't I just divide both sides by x? And the inequality is preserved.
Because x isn't equal.
Well, I mean, it's a number. I mean, you can divide both sides of an inequality by a number. We did it over here, right? All right, here we had minus 14x, minus 4x is less than or equal to 14. So we divide by -4 and flip the inequality around. divide the inequality by -4 and flip the inequality around?
Is it because x can be more than one number?
Exactly. You don't know if x is positive or negative, so you don't know whether to flip or not to flip. You can't do that. You don't know whether you need to flip the inequality or not. X is an unknown. It could be positive, it could be negative. In some instances, it's positive, and in some instances, it's negative. So, in some sense, it's both positive and negative. So, you don't know whether to flip or to not flip. You can't determine it. Okay? So, when solving inequalities, you can never divide by x or any expression, including x. Except x squared. I could divide by x squared because, x squared is positive. But that's problematic for other reasons as well. So how on earth do you solve such things? It's always done by factoring. Always. Always done by factoring. So x squared, so we'll just do this one I was just talking about. X squared bigger than or equal to 9x. Okay, you can never divide by x, so don't do it. You must factor. Can't factor, then well, you're you've got you've got other problems to deal with. Then for quadratics you can do it, but so you can never divide by x, etc., because you don't know if x is bigger than 0 or x is less than 0. Or x is equal to 0. If x is equal to 0, you can't divide. Period. You don't know. Okay, you must factor. You must set the other side, one side to 0, and factor the other. Set one side to 0 and then factor the other side. So here we got x squared minus 9x. So I subtract 9x from each side. So I got x squared minus 9x is bigger than or equal to 0. Common factor of x looks like that. Yeah? So, was it bigger than or equal to or bigger than? Bigger than or equal to. Okay. When is this polynomial equal to 0? It's equal to 0 x times x minus 9 equals 0 when what? X is
equal to 0.
Or 0 for this one. What about this one? When is that factor 0?
9.
9. So we are interested in when is x times x minus 9 bigger than or equal to 0. Well, first of all, it's equal to 0 at 0 or 9. So let's put 0 and 9 on the number line. Here's the 0, here's the 9. And we're going to use solid dots because they're going to be part of the solution. Right? Bigger than or equal to 0. X squared minus 9x bigger than or equal to 0. Well, we're equal to 0 at 0 and 9. So that's part of the solution. And now what we're left with are these three intervals. Right? So test the intervals defined by the 0 solutions. Well, so in this interval here, less than 0, pick a number. Pick a number in here. What's your favorite number in that interval?
-1.
-1, perfect. All right, -1. Any number will do, okay? Just pick -1. Okay, well, x times x minus 9 is what? Or x minus 9 is what? So I'm not interested in what it is, just as positive or negative. Well, x, when x is equal to -1, is a negative. X minus 9, when x is equal to -1, is -10, which is negative. Negative times negative equals what?
Positive.
Positive. Yeah, so this interval is part of the solution. Yeah? So any number, so like -1 and any other number in this interval, -10, -1 million, that is a solution to this inequality. So x times x minus 9 being 0 or positive. How about this interval? Pick a number in here. Say x equals 1. Well, x, when x equals 1, x, when x is equal to 1, is positive. X minus 9, when x is equal to 1, is what? Positive or negative?
Negative.
Negative. Positive times negative is?
Negative.
So that's not part of the solution. Right? That's where x times x minus 9 is less than 0. So it's not part of the solution. Pick a number in here, in this interval, x equal to 10, say. So now x times x minus 9 is what? Well, x is 10, that's positive. And x minus 9, 10 minus 9 is 1, that's positive. Positive times positive is positive. That is bigger than or equal to 0. So this is part of the solution. Right? So the solution is graphically right here. Right, and the other way you can write this is, using inequalities. So this is x less than or equal to 0, or x is bigger than or equal to 9. Or you can write it with intervals, right? And with intervals, we use this union symbol. This union symbol is U. Or you can use the word or, it's fine. So it's 9 to plus infinity along with minus infinity to 0. Square brackets because the endpoint is part of the solution. Okay. So the solution is graphically shown above. Using inequalities looks like that. Using intervals looks like that. Let's try another example. How about this? So x squared is less than 6x minus 8. Solve for x. Okay, again, you cannot divide by x. Not that you'd want to over here, because 8 isn't divisible by x. What you have to do is move everything over to the left or to the right, and then factor. So I'm going to subtract 6x and add 8 to each side. So I'm going to get x squared minus 6x plus 8 less than 0. This one factors as x minus 4, x minus 2 less than 0. Okay, notice x minus 4 times x minus 2 equals 0 when what? X equals
4 or 2.
4 or 2. So you take those numbers, okay, put them on a number line, and here we're going to use the open dots because they're not part of the solution. Those numbers there. That's just ugly looking, isn't it? Right, because at 2 and 4 were equal to 0. So we want less than 0. So again, we've got these three intervals. Now we test them. Pick your favorite number in this interval. What's your favorite number? It better be the same as mine. As my favorite number.
0.
0. Good. So it doesn't have to be the same. Just something easy to work with. A number that's easy to work with. Well, when x is 0, x minus 4 and x minus 2 are both negative. So their product is positive. So this is not part of the solution because we want that the product is less than 0. Pick a number in here, 3. Well, x minus 4 is positive, is negative. 3 minus 4 is negative 1. 3 minus 2 is 1. That's positive. Negative times positive is negative. So this is part of the solution. Right? Because we want that product is less than 0. Negative number. And pick a number in this interval, x equal to 5. Right? X minus 4 and x minus 2, they're both positive. Positive times positive is positive, so this is not part of the solution. Right? So, the solution to this is, in terms of inequalities, minus 2 is less, or not minus 2, positive 2 is less than x, is less than positive 4, and as an interval notation, it's, square bracket 2, square bracket 4, or, round bracket 2, round parentheses blue 2, round parentheses 4. Okay, so the idea is with polynomial inequalities, you factor, and then you graph where the zeros are on the number line, where the zero solutions are, and then you test the intervals that are left over. And this works just as well with rational functions. Because, multiplication and division, by positive and negative numbers gives the same property. Positive divided by positive is positive. Positive divided by negative. Negative divided by positive is negative. And negative divided by negative is positive. It's the same idea. Right? Basically because the reciprocal of -1 is -1. So how about this? So solve for x. Where you have x plus 1 over x minus 1 squared times x plus 4, and say we want that to be bigger than 0. So it's all factored, nice and neat. Right? Where are the zero solutions? Well, for the top and the bottom. X minus 1 squared x plus 4. Now, where are the zero solutions on the top and the bottom? Where is the top equal to 0 or the bottom equal to 0? Where does that happen? Well, the top is 0 at -1, right? And that's not going to be part of the solution. So we use an open dot. The bottom is equal to 0 at 1, right? And that's not part of the solution. And the bottom is also equal to 0 at -4. And that's not part of the solution either. Right. They don't have to be properly spaced. So, right, you have your factored fraction on the rational function, factored on the top, factored on the bottom, as much as possible. And then you graph where those zero solutions are for the top and the bottom. Same thing with the polynomial inequality. You got to factor the polynomial and then graph where the zeros are. There's no top and bottom for the polynomial. There's just the top of the polynomial, right? So but same idea. And now you test the intervals. All right, so here we've got 3 zero solutions, so we've got 4 intervals to look at. So in this interval, we'll try x equal to -5. X plus 1 is negative. X minus 1 squared, well, since it's a squared, it's going to be what, always?
Positive.
Positive, it's always going to be positive. And then the x minus 4, that's negative. Right, so I have negative divided by positive times negative, and that's equal to what? Positive or negative? Positive or negative?
Positive.
Positive, right? This is negative on the top, negative on the bottom. Right? Negative on the top, negative on the bottom. Negative divided by negative is positive. So that's part of your solution, this interval. Next, -4 to -1. So try like, say, x equal to -2. -2 plus 1, well, that's negative. The x minus 1 squared, again, it's a square, so that's always positive, as long as it's not 0. And then the x plus 4, well, -2 plus 4, that's positive. So the whole thing here is negative. So negative divided by positive times positive is negative. So that's not greater than 0. That's less than 0. All right, so this is not part of the solution here. All right, from -1 to 1, we'll try x equal to 0. So for x equal to 0, we have positive. This thing is squared, so it's just positive, positive, positive. So the whole thing is positive. So that is part of the solution. And then for this interval here, bigger than 1, so try like x equal to 2. Same thing, all of those factors are positive. So the whole thing is positive. So this is part of the solution. Right, so that's our solution in terms of, the number line. I wouldn't bother with the inequalities with this one. It gets to be a bit much. Let's just do the interval notation. So it's -infinity to 4, not including the 4, union the interval from -1 to 1, not including the -1 and 1, union 1 to plus infinity, not including the 1. So you notice we have the whole interval from -1 to plus infinity except the x equal to 1. The problem with x equal to 1 is that, at x equal to 1, this function isn't even defined because you can't divide by 0. All right, the bottom would be 0 at that point. Okay, so same deal with rational functions as it is for polynomials. You gotta push everything to the left so that you get a 0 on the right, and then factor completely the top and bottom of the rational function. So let's try one more example of a rational function. So how about, so solve for x, where you have 3 plus x over 3 minus x bigger than or equal to 1. Well, I don't have a 0 on the left or the right. Let's flip this around. Let's say less than or equal to 0. I don't have a 0 on the left or right. Okay, so let's subtract 1 from both sides so that I get a 0 on the left and on the right. -1 less than or equal to 0. Now I don't have a rational function on the left. Well, not in standard form. I have to add these together using a common denominator. So I got 3 plus x over 3 minus x, and the 1 is 3 minus x over 3 minus x, less than or equal to 0. So this is 3 plus x minus what? Let's see if we remember the common mistake that get made here. Three plus x minus what?
Do you have to distribute the negative?
Exactly. It's minus the whole thing, which means you have to distribute. It's this fraction, right? I mean, 3/5 minus 2/5, right, is 3 minus 2/5, right, which is 1/5. 3/5 minus 3 minus 1/5, is it different? Is this different than this? Come on, guys. Is this different than that?
No.
No. So the answer must be the same. Right? So this is 3 minus 3 minus 1 over 5, which is 3 minus 2 over 5 is 1/5. It is not equal to 3 minus 3 minus 1 over 5. Right? Which is negative 2/5. Right? You must distribute that negative sign. Well, you have to put a parentheses here when you subtract. It's this fraction's numerator minus this fraction's numerator, the whole numerator. Okay, not just the first term of the numerator. So the upshot of all that is you have to distribute the negative sign through the top. Okay, or put a parentheses there and take an extra step, whatever the case might be that you like to do. Okay, so this becomes what? This is 3 plus x minus 3 plus x over 3 minus x less than or equal to 0. So these guys go away. And we have 2x over 3 minus x. So we're all factored nice and neat on the top and the bottom. Okay, where is the top equal to 0 and where is the bottom equal to 0? Where's the top equal to 0? Guys, come on. Where's the top of that fraction equal to 0?
If x is 0.
If x is 0. Is 0 part of the solution or not part of the solution? Right? Remember, 0 over, whatever. 0 over 3 is 0. 0 over 5 is 0. 0 over negative 6 is 0. So having 0 on the top part of the solution or not part of the solution when you want the fraction to be less than or equal to 0?
It is.
It is part of the solution, yes. Where is the bottom equal to 0? Well, at 3. It is, so we put a solid dot. At 3 on the bottom. Is the 3 part of the solution? Well, the problem is you can't divide by 3 on the bottom, so it's never part of the solution. The fraction would be undefined. You can't divide by 0. You can divide 0, but you can't divide by 0, right? Dividing nothing into so many equal parts is every part is 0, right? But you can't divide something into 0 parts, right? When you have something and you want to divide it into parts, those parts have to contain something. So you need at least one part. That's the, semantic reason. There's an algebraic reason that's better. Anyway, so we've got these intervals here, so we test the intervals, say x equal to -1 for this one. So when x is equal to -1, the top is negative, the bottom is what? Positive or negative?
Positive.
Positive. So the whole thing is negative. All right, so this is part of the solution. This interval, try x equal to 1, top is positive, bottom is positive. So the whole thing is positive. So that is not part of the solution because we want less than or equal to 0. Try this interval here, x equal to 4. Top is positive, 2x is positive. 3 minus 4 is negative, so the whole thing is negative. So this one is part of the solution. Right, so that's our solution graphically in terms of inequalities. We have that x is less than or equal to 0, or x is bigger than 3. And with intervals, it's minus infinity to 0, square bracket 0, union 3 to plus infinity, round parentheses for the 3 because that's not included. Okay, so we want to show the answer. I mean, the inequalities, can be too messy to do, like with this one here. Right? When you have more than 3 intervals, when you have 4 or more intervals, inequalities can be really messy. So, but if you can write the inequalities, do so. But this is the main way we want to see the answer on this number line here. Although the interval notation is nice too. So do all 3 if you can. All right. So with polynomial and rational function inequalities, you have to have a 0 on one side. Okay, you got to make it 0 on one side, and you have to have the other side factored completely. So with rational functions, you have to, add together all the different terms that you would have to make several fractions into one fraction, and then factor top and bottom completely. This one was easy enough because the top and bottom were already factored after we did the addition, or subtraction, actually. All right. So section 1.8 is also about inequalities. Okay, but now we're going to put absolute values into it. Okay, so equations and inequalities. Absolute value expressions. So we did a little bit of this when we did the completing the square business, but we're going to do more of it here. And it comes up every so often in other math courses. Okay, so some rules for working with inequalities, or with absolute values. One, absolute value of A times B is equal to the absolute value of A times the absolute value of B. 2, absolute value of A over B is equal to the absolute value of A over the absolute value of B. Right? Positive and negatives, they have nice multiplicative rules, right? Positive times positive is positive, positive times negative is negative. So it's no surprise that this is the case, right? If you take A and B, the product, and make it positive if it's negative, right? It would be the same as if you made A positive and B positive, and then did the product again that way. Same thing with the division, right? I mean, there's no surprise here. Okay, please don't do this. Nothing distributes over addition. Nothing. Only multiplication. I mean, it's kind of funny that, there's some reason why aesthetically people want to distribute stuff over addition. Okay, nothing does, just multiplication. But just because multiplication does, it seems to, you know, give the feeling that other things do too. It doesn't. Nothing does. Right? I mean, like, for example, -1 plus 1, absolute value is what? What's this?
0.
0. -1 absolute value plus 1 absolute value, or what?
2.
2. The same? Not the same. Not the same. Okay? So, this doesn't work. So nothing distributes over addition. Nothing. Not logs, not sines, not cosines, not square roots, not absolute values, not squares, not cubes, nothing. Not logs. Lots of things distribute over multiplication and division, however. Like absolute values, for example. Not everything. Not everything distributes over multiplication. Sine and cosine don't. But anyway. All right, 3. If the absolute value of A is equal to B, right, then what does this mean? It means B is equal to A, or B is equal to the negative of, B is equal to A, or negative A is equal to. So A is equal to B. Let's do it right this way. A is equal to B. The thing in absolute value is equal to B, or the thing in absolute value negated is equal to B. All right. So if you're saying -3 absolute value is equal to, absolute value of A is equal to 3, this means A is equal to 3, or -A is equal to 3. So you could write it one way or the other. A is equal to B, or -A is equal to B, or A is equal to B, which is the same as A is equal to negative B. One or the other. This means A is equal to 3, or A is equal to negative 3. All right, so let's do the following. Solve for x. So how about absolute value 3x plus 10 equals 25? Okay, so we have this absolute value expression equal to 25. So this means that 3x plus 10 is 25. So it turns this one equation with an absolute value on the left turns into two equations. Right? A is equal to B, or the negative A is equal to B, or A is equal to negative B. So this means 3x plus 10 is equal to 25, or 3x plus 10 is equal to negative 25. So the single linear equation turned into two linear equations. So you have to solve them both now. So let's subtract 10 from each side. So 3x is equal to 15 for this one. This one is 3x is negative 22. So this says x is equal to 15 over 3, which is 5. And this one says x is equal to minus 22 thirds. Okay, so you get two solutions in such an instance. All right, so absolute value something equals 25. Absolute value of A is 25, means A is 25, or minus A is 20. How did I get it in minus?
Where'd you get 12?
I don't know where I got the 12 from. Negative 25. Let's do that. So minus 35. So x is minus 35 over 3. So absolute value of A equals 25 means A is 25 or A is negative 25. So that's what we did here. 3x plus 10 equals 25, or 3x plus 10 is equal to negative 25. All right, so similar example. All right, solve for x. Okay, well, with this one, okay, again, what you should do is to solve this equation first by putting the absolute value expression on one side. Okay? Or you could do the following. Well, let me not do the following. Let's just put the absolute value expression on one side. So let's subtract everything else from the left and put it over to the right. Like that. By the way, is the right negative or positive? This is positive. The left is positive. It's absolute value. Is the right positive or negative? With all those negative signs floating around. It's a trick question. Not really. I don't know what a trick question. The answer is you don't know. I mean, it looks like it's negative, but it doesn't have to be. If you put x equal to negative 10 on the right, then it's 29, that expression, right? An absolute value of something, of course, has to be equal to a negative or a positive value. Okay, but that doesn't sort of disqualify this. Okay, but once you get it into this form, now you apply, this thing again. If absolute value is equal to b, right, and b is positive, of course, b has to be positive. Then a is equal to b, or a is equal to negative b. Let's write it that way. Right, if absolute value a is b and b is bigger than or equal to 0, then a is b or a is equal to negative b. So you just apply that here again. So this tells us that 2x minus 5 is equal to 3x minus 1. Or 2x minus 5 is equal to the negative of negative 3x minus 1. Okay, so 2x minus 5 equals minus 3x minus 1, or 2x minus 5 equals positive 3x plus 1. So now we've got these two linear equations. You must solve them simultaneously. Okay, so with this one, I'll add 3x to each side, and I'll add 5 to each side. Right, so adding 3x to each side gives me 5x over here, and adding 5 to this side over here gives me 4, so x is equal to 4 fifths. Over here, okay, I'll subtract 2x from each side and subtract 1 from each side. So I get a minus 6 on the left here, and then just x on the right. So x is negative 6. All right, so the first step in an equation that has an absolute value expression would be to isolate that absolute value expression on one side of the equation by itself, so that you can apply this, this transformation. Absolute value A equals B means A is equal to B or A is negative B. Okay, so the goal is to apply that, to eliminate the absolute value symbol. All right. Inequalities absolute values and inequalities. Okay, so if B is bigger than or equal to 0, then, okay, absolute value of A less than B means, right, minus B is less than A is less than B. Here is B, minus B and B, and A is inside here. Absolute value of A less than B. For example, if I said absolute value of A is less than 3, it means minus 3 is less than A is less than 3. A is between negative 3 and 3. A would have to be between negative 3 and 3 in order for its absolute value to be less than 3. Similarly, if we had less than or equal to, then you get the same thing, just with two less than or equal to symbols rather than less than symbols. If you want the absolute value of A to be bigger than B, well, that means that either A is bigger than B, or A is less than the negative of B. And on the number line, it looks like this. Actually, that's fine. So here's negative B, and here's B. And if you had bigger than or equal to, oh gosh. Similar to that, except you get, inequalities in intervals that contain the B. All right? Right? So, I mean, like, for example, here, if you want to say the absolute value of A is, hold on. I'm going to have to reboot this. Oh, it's 10:55. Come on. Okay. For example, if you wanted to say absolute value of A is less than 3, or bigger than 3, well, here's negative 3, and here's 3. right? So A would be over here, 4, 5, or 6, or down here, -4, -5, -6, right? Those are all numbers whose absolute values are bigger than 3. These negative numbers down in here, and these positive numbers up in here. Okay? So the next thing to do is to solve some inequalities that use, these absolute value expressions, and we'll do those next time, okay? All right, so have a good day, everyone. I will see you tomorrow, and, I have open office hours. I'll send you the link in the email after class from 11:30 to 12:30, okay? If anyone wants to come and see me.